Hey everyone! Welcome back to Decode with Priyo, the place where coding becomes simple, logical and super fun. Today we are decoding a very interesting LeetCode problem. The name of the problem is smallest integer divisible by k. And trust me, the trick behind this one will blow your mind. So let's recap the problem. That what the problem says. It says that you will be given a positive integer k. Fine. You need to find the length of the smallest positive integer length. Okay, what that mean? You need to find the positive number which should be greater than 0. Second, you need to find the smallest one. You don't need to return the number. You need to return the length of that particular number. Cool. Then what the number n is? N will be divisible by k, first point. And second is the n only contain digit 1. What that means? Means the n could be 1, maybe 1, 1, maybe 1, 1, 1, 1. Maybe 1, 1, 1, 1, 1, 1 and so on. Nothing else beyond these numbers. The range of the number should be like this and every number should be contained only one digit. Okay, so let's recap these examples. For this example says that first is k equal to 1. It means that you need to find a number which is divisible by k. So the smallest number which is divisible by 1 is 1 itself. And what is the length of this number? 1. So it is written 1. Now let's go for the 2. Now, if you start from 1 and go just increasing the numbers of each particular numbers. So, is there any number possible of this series which is divisible by 2? No, right? Because 2 is an even number and every number will be generating is odd. So, that's the reason it is minus 1. What's about 3? The smallest number which is divisible by k, which is 3, is 111 and the length of this is 3 and the number is also contains only ones. So I hope you got the problem. Now let's decode the brute force. After that we'll go to the optimal one. So what brute force you are thinking? You may tell me that hey Priyo, just we don't need to do anything. We'll start a while loop. The while loop will try till infinity. There will be only the true values and each values I will check that which number is divisible by k. I will start the number from 1. Every time I will check that does my number is divisible by k or not. If it is divisible by k, I can return the number, right? And if it is not divisible by k, so then I will go to the next number. Now the problem is how can I go to the next number? It is very simple. The next number will be num into 10 plus 1. What is my first number? Is 1. So what will be my second number? 1 into 10 plus 1, which is 11. What will be my next number? 11 into 10 plus 1, which is 111. So in this way, I can go to this while loop. So, but here is the challenge. The number can be super big, maybe 1000 digit long. Does any long integer can store this? No, I think. So we need to use mathematical operation. Also some modulo tricks. Why? So let's understand the problem. Here I am taking an example which is k equal to 7, where I will start a number from 1 and I will go. Every time I will check that is it divisible by k or not. So I will start from 1 and I will try every time that is it divisible by this or not. Okay. So I am thinking that yes, I can go, and if I move more further, like it is 1111 into 10 plus 1, which is 6 times 1 modulo k, which is 0. So I found my number. And what is the length of this? The length is 6. Cool. So I found. So is it possible to me? Why not I use some modulo tricks? So the first things you are seeing that 1 modulo k is 1. So rather than number, why not I check the modulo? So I took this modulo, which is 1. So 1 into 10 plus 1, which is 11, modulo k, fine. Perfectly fine. Rather than 11, if I take 4, does it works? Let's see. 4 into 10, which is 40 plus 1, which is 41. So does my 41 modulo k is 6? Yes, it is. Now let's go for the 6. You may be wondering why 41 modulo 6? Because 7 into 5 is 35 plus 6, which is 41. So the remainder is 6. Let's, rather than 111, I am using 6. 6 into 10 plus 1, which is 61. What's the modulo of 61 modulo k? Is 5. Is it correct? Yes. Okay, let's move forward. What is 5 into 10 plus 1? Which is 51. 51 modulo k Is it 2? Yes, because 7 into 7 is 49. So 49 is plus 2, which is 51. What about next? 2 into 10 plus 1. 2 into 10 is 20 plus 1 is 21. So 21 modulo k, yes, it is. So it means I found my answer, which will be my this. It means this particular number is divisible by k. But now the question is, Priyo, okay, fine. I found that how I can move forward rather than storing a huge number. But how can I decide that what will be the length of my number? I am not able to store the numbers. I am storing 21 and definitely 21 not will be my answer. So the answer is very simple. Let's see. Here we need to use the cyclicity principle. What it says? What it says that if you do any modulo operation, what I'm saying, it is a very important tricks. Remember in your life. If you do any modulo tricks, okay, let's suppose do any number. The number can be go from, let's say, 1 to infinity. If you do the modulo of this particular number, the answer should be always in the range of 0 to k minus 1, which is both are included. Nothing will beyond that number. That's the power of modulo. It means suppose that you are getting a 3, you need to do the modulo 3. So let's say 0, 1, 2, 3, 4. So if you do modulo 0, it will return 0, it will return 1, it will return 2, it will again return 0, and again it will return 1. So the things you are saying that it is repeating, or there is a cycle present in this world. So that's the things. If you do again 21 plus modulo is 0. So if you do 0 into 10 plus 1, which will be 1. See, the 1 is already again present here, and you will again repeat the cycle. I hope you are getting the number will definitely be, if it is divisible by something, then definitely it will be from 0 to k minus 1, right? But it means that I need to run my loop for the k times. So can I say, rather than 0 to k minus 1, I can do also 1 to k, right? So I will run a for loop. The for loop will run k times. So let's make a for loop, which is for int I equal to 1 to I less than will be k, I plus plus. I will run a for loop. That particular for loop will basically run for the k times. Okay, so I run my for loop. Every time I will just store my number. The number should be definitely start from 0. Okay, so I store my number, which will be num into 10 plus 1, right? And I said that we'll not definitely store the whole number, we'll store the modulo. So I will do a modulo with k, okay? And I will just check, simply check, does my number equal to 0? Because it's a remainder, right? Okay, let's change the name. So does my remainder equal to 0? If it is 0, then I can say, I can really return the I. Why? I will start I equal to 1 and I got my number from here. This time my I become 2, this time 3, 4, 5 and 6. So you are saying that the number will be divisible by k. The length of that number is exactly equal to the I. So can I say that if I got the remainder equal to 0, I just need to only return I? Yes. And outside of the for loop, it means that I run my cycle, I go from 0 to k minus 1, but I didn't able to find any numbers which is divisible by k. So it means I need to return minus 1. So I hope you got the problem. It is very, very simple. But the tricky one is to only doing the modulo operation, because you cannot store a huge number in an integer. So let's decode the code. So I'm going here and it is very simple. So what I'm saying that I will take a number called remainder and it will start from 0. Okay. Then I will run a for loop which will go from I equal to 1 to I less than equal to k, and every time I will increase the values. Just I need to check one. Does my remainder, what is my next remainder? So the next remainder will be remainder into 10 plus 1. And definitely this particular number will be very big, right? So what the things I need to do? I need to do just modulo k. Fine. And I need to just check, does my remainder is equal to 0? if it is 0, just do nothing, return I. And if I outside of the loop, if I go outside of the loop, I just need to return -1 because I'm not able to find anything. Okay, let's see that does my code is working fine or not. Okay, all the test cases are run. Bingo. So we have completed the question. Can I make it more optimal? Let's go to the problem again and find some hidden threads. So just tell me one thing. What is my number array? The number array contains 1, 1, 1, triple 1, quadra 1, penta 1, and so on. Can you tell me that which particular numbers are divisible by this? Sorry, I mean which numbers can divide these numbers? Definitely some odd numbers. Is it possible with some even numbers? No, I think. Here is a twist of odd, I will tell you later. So if I want to divide any number from even series, is it possible? What the means even series? Means 2, 4, 6, 8 and so on. You cannot even divide any number from the even series. That's the reason if my k is even, I cannot find any solution. So before going into my code, I can put a check that does it is even. If it is even, then return -1. One more things. In the odd, there is also hidden a odd which also cannot divide these numbers, which is 5. Can 5 divide these numbers? No. And does multiply of 5s means 5, 10, 15, 20, 25. So does these numbers also can divide this? No, right? So we found a hidden treasure. If my k modulo 2 equal to 0 or my k modulo 5 equal to 0, do nothing, just return -1. So in this way, I don't need to go inside the loop and I can reduce time complexity little bit less. So let's go to the code and optimize it. So what I'm saying that do nothing, just check a simple check that if my k modulo 2 equal to 0, or we can do something like this, and k modulo 5 equal to 0, then return simple -1. So here is the small optimization. You definitely need to tell this to the interviewer. He will be very impressed about this particular thing. So I just did this, and yes, my test case all run, and let's check this, all my test cases run. Okay, so here you can see that it is same. So I hope that you got the problem. Now let's go for the time complexity. The time complexity will be, I just only run 1 to k. So it means the time complexity will be definitely O of k and nothing else. And that's how you solve LeetCode 1015 like a pro. If you found this explanation clean and easy, hit the like button, subscribe to Decode with Priyo, and I will see you in the next decoding session. Till then, keep coding and keep growing.